Hello, my viewers. My name still remains Gbenyong Sunday, and I welcome you all to my YouTube channel on PU Formal Academy. Looking at my previous presentation, I've been able, so far so good, to classify the raw material used. Also, look at the role played by those individual chemicals that was earlier stated. But in my presentation today, I will be looking at how you can design a good formulation that help you save cost in your production or process. That is to say, principles of cost saving formulation in the production of flexible polyurethane foam. So, looking at this topic, the key word is cost-saving formulation. And what is this formulation is all about? But before I define what formulation is, let's critically look at this example. In the entire production process, is not only in the foam industry, provided that you are converting raw material to a useful product, those products can be consumable or non-consumable. Provided that there is a combination of 2 or 3 chemicals to give you that product. The fact that you're able to bring them in without affecting the end product, that is what we call formulation. Formulation in that a lot of us practice this. Some of our women in kitchen, they will use different kind of ingredients to cook a well delicious meal. Some of them will also use it, the food will not be delicious. So this is the lack of combination of certain proportion of this ingredient to give you that food. So in the context of production of flexible polyurethane foam, you know, I did say that we have polyol as a major raw material, toluene diisocyanate as a main chemical or major raw material. We have activator, thin catalyst, amine, silicone or additive. We have blowing agent, MC, water. Then we also have other pigments like yellow, blue, green, and etc. So these chemicals are coming together to give you a particular product. So formulation means the ratio or proportion of individual chemicals in respect of the density that want or intended to produce. You see, if you are using a continuous process method, it is going to be defined in respect to kg per minute. Kg per minute, because it is a continuous process. If you are using batch process method, it's in kg because it is batch by batch. So the chemical are being measured in kg. But in continuous process, the chemical are continuously dispensed, reacting in kg per minute in a continuous manner. So that is just the difference. Now, we look at density. Density here means mass all over volume. That the unit is in kg per meter cube. So the volume here is made up of the mold. The mold, the volume is made up of the mold, which is made up of the length times height times width. Okay, in cm, then you convert it to meter, fix it here. Now the total mass of the block, when that mass here divide, will give you the density that you want to produce. And in this density, there are different classes of foam density. There are one, we have low density. Two, we have medium density. And three, we have high density. Now, high density is what we describe as heavy duty products above that is from 25 and above. Okay, 25 and above. Then medium density, we take it from 22 to 24. Then low density, we take it from 10 to 20. Could be state density, but this is not the issue. Here is not the issue. The issue depends on the kind of standard in that country that is available or regulating this density based on this. What I'm saying is this: country A may say this is low density, whereas country B may say this is high density. So this is what I'm trying to say, that the density that falls between 22 to 24 is low. Another country may say density that fall between 22 to 24 is high density. Okay, so it depends on the standard of that country. Okay, so it is not fixed. And what is this standard? Remember, this standard is not set by one company or one entity. Standard is established in a consensus manner, whereby those in the industry who manufacture the product, technical staff in the standard body, and that of those in academic coming together to discuss and reach a consensus agreement and come out with a range that will now regulate this standard. Unlike Nigeria, we have Standard Organization of Nigeria. Standard Organization of Nigeria do not make standard, rather this body regulate standard. Okay, so it all depends. So this number, it does not matter. So it's all depend on the country you are. So you just look for standard and see what standard wants and do it according to that standard. Now, having known this classification, we move this one into two types of density in terms of production. Two types of density. We have desired density. Then we also have calculated density. Those are the two things that guiding you who want to produce. And how does this occur? Desired density means those one you intended to produce or you want to produce. Okay, this one is that you are producing in a laboratory scale. You now check the density of the final product. Maybe you intend to make the density of 30 here. At the end of that production or laboratory trial, you have 28. You can still carry out the test by adjusting the formulation that will give you this 30. So that is how it's been done. And in terms of formulation, formulation is not a copy and paste document. You cannot stay in United States of America and give me formulation in Nigeria. I cannot stay in Nigeria and give you a formulation in United States of America. The reason in that I do not understand the atmospheric condition of that place and the factory location. We are going to look at this factor that affect PU for formulation at the same time during the process. So it's not a copy and paste. It's something that you need to put into several consideration: the temperature, the weather condition, the types of equipment you are using, the types of raw material you are using. So those are the things. So the best knowledge is that how do you save this course is that you first select the raw material. Raw material selection is the key. And I did say that for you to have the best raw material that you want to produce a product that is accordant with the standard and also that of your customer demand or specification is the raw material. Now, the best way to also reduce costs is by introduction of filler. Okay? Introduction of filler. How do filler is being integrated in PU formal production? Because filler is just like a substitute for polyol, a locally sought material that is used in substitution. And I did say that under the industrial conversion, polyol is still impaired by 100. Okay? The reason of this 100 is to enable you scale up, accurately determine this formulation. Okay? Now, by bringing calcium carbonate, the idea of calcium carbonate is to reduce cost of that production without even affecting the quality. Bringing it filler depend on what you want. It's optional. Factory A may decide to use 10%. Factory B may decide to use 20%. Factory C may decide to use 25%. All these things depend on one, the property of foam that they are looking for, depending on what their customer wants. If you want your foam to be a bit harder, then raise this percentage. Increase this percentage. If you want it to be soft and durable, then decrease this percentage. Okay? Now, as you are increasing this percentage, you have to also watch the property. When we say hard foam and soft foam, you can even still use calcium carbonate and your foam will still be softer. You can even use calcium carbonate, it will be harder. You don't even use it, it will be hard. If you don't even use it, it will be soft. So it's all depend on formulation. So formulation is a very ideal and essential parameters in the production of flexible polyethylene foam. The fact that you can produce a good foam is not a question, okay? But the question is that your good foam, is it economical? If it is yes, then you are good to go. And what makes your foam economical is to sit down and carry out a laboratory test in that particular formulation or density. You don't need to carry out assumption, okay? You carry out what we call a pilot trials, trying to test and test and test and test and varies the composition of that chemical for you to get the right density. And what about your machine, the types of machine you are using? You must also understand, for those of you who are operating in a large scale, that is a continual process, all machine technology is not the same. We have machines that are known as higher output. We also have machines that are known as the lower output machine. So you have to look at this, because when you use a lower output machine, maybe you bring a formulation and a higher output machine, it may give you the density, but the process may not be the same. You may have a fast reaction or a slow reaction, so it's all depend. You may even have foam collapse because you do not understand the machine technology. So the most of the way you can save costs in your production is the engineer or the production manager or the production chemist to understand the machine technology that will enable him to design a formulation that is compatible and suitable to that machine. Now, so in calcium, it is best done in substitution. 100 minus 10 equal to 90. That is 10%. 100 minus 20 equal to 80. That is 20%. 100 minus 15 equal to 85. That is 15%, and so on and so forth. So you are using 10 parts of filler to replace 90 of this, giving you 100. You are using 20 parts of filler in this to give you 100. You are using 15 parts of this in this to give you this. So this is how it's being integrated. In this case, it's simple. Tell everybody that you are using, okay, look at this one. This is filler. This is polyol. In a real context, the cost of this is far cheaper than this. This is a petrochemical product, highly expensive. This is filler. So using this to replace this, you are saving cost a lot. Now, it's not only this, but then what of the entire processes? The processes such as the blending of the raw material, the temperature control, the entire preparation, the routine maintenance of the machine, and the calibration of all the dispenser equipment such as your weighing balance, which is very important, your polyol line, you check your filters, you ensure that machine is properly set before you go into the entire production. Now, before you go into entire production, as a manufacturer that is using a continuous process, you must also put safety parameters or safety measures in place, okay, regarding your formulation techniques, in terms of choosing your TDI index that will enable you to meet up with that formulation. We are going to look at that, how to calculate this TDI index and design a formulation that is economical and also safe. Then we look at the calibration of all the dispenser equipment, such as all the chemical lines and your weighing balance, as well as your checklist. The checklist has to be developed. For example, you want to design a checklist, you must ensure that those things that as a human you can easily forget is the checklist that will put into your memory. Just go to the checklist document and check what that are lacking for the commencement of the production. Checklist will tell you so that you assess before you commence the production. Is it not interesting? So there is no way you will follow me up that you are not going to learn a lot. By this knowledge gained so far, I want to share it to you, help you develop a standard production or process that will help you optimize your production or process, increase efficiency and your productivity, thereby saving money. So the best things to do is to like my page on your notification bell, so that whenever I upload a new video, you will notify. Then share my video to other people who are also in need of this idea. Knowledge share is very good in a society. So the best things to humanity is to share knowledge, and that is what we are trying to do. Is that not interesting for you? Thank you, my viewers. Bye bye.